Hi everyone, and welcome to another video of the SAFI webinar series. In this video, we are going to have an overview of the core integration line. The integration line command allows to associate a group of plates and/or members to a reference axis system called an integration line. At each longitudinal position, all forces of the members and plate elements crossed by the cutting plane are summed and brought to the center of the integration line. The position y equals 0 and z equals 0. It is important to keep in mind that the convention of the integration line results is identical to the convention of the member results. For example, the moment mz is a moment around the z-axis that compresses the top fiber. We can edit any type of integration line using the command Edit Integration Line in the Edit toolbar or using the shortcut G. Let's start our demo. In this example, we have three equivalent beams. The first beam is modeled using a member with an I-shaped section assigned to it. The second beam is a hybrid beam. We used finite element plates to model the web of the section, and we used members to model the flanges of the I-shaped sections. In this case, these sections have rectangular sections that have the same dimensions of the I-shaped section flanges. The third beam is modeled entirely using finite element plates for the web and the flanges. Integration lines can be used to display the results on a group of members, end plates, or a group of plates as an equivalent beam. To do that, we first need to create groups of elements. For the hybrid model, we select the elements including the plates and members, and we save them as a selection group. We do the same operation for the beam that is composed only of finite element plates, and we save them as another selection group. The next step is to create the integration line. To add an integration line in the model, we use the command Add Core Integration Line Type, and then we select the start of the integration line and the end of the integration line. So here, we will select the starting point and the end point of the integration line. In the integration line attributes, we need to select the type of integration line as core. Next, we need to select the element group. For the hybrid model, we need to assign the selection group hybrid plates plus members that we created. Then we click OK. When an integration line is created and associated to a group of elements, we see the integration line axes. The axes of an integration line is similar to the axes of a member. In this case, the x-axis is the axis along the beam. Let's create another integration line for the beam that is composed of only finite element plates. We will create the integration line in a similar manner, selecting a starting and an endpoint. The type is core, and we will assign plates for the element group. We then click OK to validate. Let's run the analysis. In the Analysis Results Display option, we see the moment MZ and the shear FY to display graphically. We click OK to validate. Now we can see that for the hybrid model and the model composed of only finite element plates, we are able to display the moment and the forces diagram along the beam. When we have a finite element plate, we can display the finite element results. So for example, in this case, I'm going to display the von Mises stresses. Using the integration line core allows the user to display the results on a group of elements or plates as an equivalent member, as we can see for this example. Thank you for watching, and catch you in another one of our webinar series videos.